All right, today we will cover chapter 4, and that we are going to explore the relationship. Okay, this is on relationships between two numeric variables. Okay. So what are what's an example of two numeric variables that might have a relationship?
Age and weight?
Yeah, age and weight. Okay, sure. All right, so we could go around. We can go around and collect data on a whole bunch of different people, and we record their age and we record their weight. Okay, and what do you think we will see? Will we see a relationship between age and weight? Okay. So what we'll probably see is that for children, there's going to be a strong relationship between age and weight, where older children weigh more than younger children. Okay. In general. But for adults, the relationship may or may not be that strong. Okay. I'm not sure if they're how strong of a relationship. Do older adults weigh more than younger adults? Maybe a little bit. Okay. In general, people in their 20s generally weigh less than when they are in their 30s and 40s. Okay, but it's not a very strong relationship. Okay, because you'll have many people who are in their 20s that weigh more than people who are in their 30s or 40s. Okay, so the relationship isn't as strong. But children, the relationship is quite strong. Okay, what else might have a relationship between two numeric variables?
Shoe size and height have a relationship?
Shoe size and height?
But actually, would shoe size be numeric?
Yeah, shoe size could be numeric, right? Because you could say I wear a size 10 shoe and somebody else wears a size 11 shoe, and you can say so-and-so is one shoe size larger than so-and-so. That's, if you can make comparisons with the numbers, then it's a numeric variable. Okay, even though there's no direct measurement. Okay, if you could say, if it makes sense to say, oh, so-and-so is one shoe size larger, then you can say that's numeric. Okay, so shoe size and height, yeah, there's probably a relationship. In general, people who are taller have larger feet. In general, but it's not very, very strong. Okay, you're going to have a lot of scattering because you're going to have tall people who have smaller feet than, and some people who are short and have large feet. Okay, but overall, if you look at shoe sizes and height, you will see some kind of relationship, just because it's all part of the skeletal system, and bones tend to increase or decrease together. So yeah, so you can say shoe size versus height. Okay, so again, in general, taller people larger feet. Okay. Again, this is all very in general. Okay. So in statistics, we just talk about these general trends, and of course, any individual, you might be able to find a tall person who has little feet and they don't fit the norm, or maybe you find a short person who has big feet and that person doesn't fit the norm. But in general, there might be a relationship. Okay. And there's all sorts of other things, okay? Here is if we look at many different countries, okay? So for different countries, okay, we can look at the literacy rate and the birth rate, okay? Okay. So in the United States, the birth rate is, what is the birth rate? Do you guys have any idea? What is a number what does a birth rate tell us?
The average number.
It's the average number of children that a woman will have. Okay, so
Probably 2 to 3.
yeah. So in the United States, the birth rate's around 2.3. Okay, something around there, a little over 2. It fluctuates, but around 2.3, and that just means, in general, the average woman has about 2.3 children. Okay, nobody actually has 2.3 children. They either have 0 kids, or 1 kid, or 2 kids, or 3 kids, or more than that. But if we took an average, it's around 2.3 children. Okay, but you go to other countries, and you know the birth rate might be 5 children. Okay, or other countries the birth rate is like 1.5 kids or something like that. Okay, what's the number of children? What is the birth rate required to have to sustain a population? 2 children. 2 children. Okay, so if a woman does not have 2 children, okay, if the birth rate is less than 2, the population is going to decrease over time, because if you think about it, the woman needs to replace herself and her partner. Okay, that's generally the mindset. So so in countries where the birth rate is smaller than 2, they will experience a shrinking population over time. In countries where the birth rate is larger than 2, they will experience growth. Okay, and so anyway, different countries have different birth rates, and also different countries have different literacy rates. Okay, and literacy has only 1 T. Okay, so. All right, and what we see here is what do you think the trend is between literacy and birth rate? Yeah.
Higher literacy rates, lower birth rate.
Yeah, in general, countries with higher literacy rates will have lower birth rates. Okay, so. And this is just, these are just trends, okay? So, so does that mean if we want to increase literacy in a country, we've got to prevent the women from having children and decrease the birth rate? No, okay, it doesn't work that way, all right? But these are trends that we see, okay? So just looking at different countries, we see, what we see is that in general, countries that have low literacy rates, okay, so meaning not much of the population is able to read or write, countries that have lower literacy rates generally have higher birth rates, okay, they have more children. And countries where the literacy is high, in general, have lower birth rates. But that's That's not always the case. Yes, question.
So it's an inverse relationship.
So we call this a negative trend, okay? And we'll talk about what that means. Because, for example, Ireland has a high literacy rate, okay? They're actually very, have a strong technology sector and whatnot. But they also have a high birth rate, okay? About close to 4, 3.9 as their birth rate, okay? All right, so this is just, these are just some examples of where we can look at relationships between two numeric variables. And so all the stuff we're talking about today only applies when we're looking at two numeric variables, okay? And one of our first tools, so displaying a relationship, okay, we're going to use a scatter plot. So let's say this was shoe size versus height. Okay, and so shoe size, let's start off with shoe size of 4, 5, 6, 7. So we'll just say these are U.S. male shoe sizes. So women who wear a size 8 shoe would register 6 on the U.S. male shoe size. Okay, and then over here we've got heights. So I don't know how 72 inches, 70, whatever. Okay, so here I've created the axes, and what we would do is we would go through our data and we would draw dots wherever people exist. Okay, so here I put a dot right here. Okay, and this dot represents a person. Okay. And what is the shoe size of this person, and how tall is this person?
Size 10, 72 inches.
Okay, so yeah, I mean, maybe my graph isn't perfect, but yeah, this is someone. This person has their shoe size, let's say is size 10. They wear a size 10 shoe, and their height is, let's say 70 inches, okay? Now, whatever, if we had graph paper, we could be a little bit more accurate, all right? And so let's say there's a woman and she wears a size 7 shoe and she's 6'4", okay? So this is a shoe size 5 and height 5'4" is 64 inches, okay? And we go on like that, okay? And we do this for every single person in our data set, and we graph all the dots. Okay, so every dot represents a different person with different shoe size and different height. Okay, and overall, if we were to create a trend, we would say there's some kind of positive trend here. So here, is that okay? We've got a bunch of dots and we have an overall trend line, right? Okay. Is there a question here? Okay. And so we would say this is a positive trend or positive relationship. Positive association or relationship, whatever you want to call it. And that, what that means is that as one variable increases, okay, or larger values for one variable generally correspond to larger values of the other variable, and smaller values of that variable generally correspond to smaller values of the other variable. Okay, so if we drew the literacy rate versus birth rate, okay. Each dot, what does each dot represent? No.
Person.
No.
Bird.
Country.
Each dot represents a country, okay? How can you have a literacy rate for a person? It's either they know how to read and write or they don't, okay? But over here, each dot represents a country. Okay, and you're gonna have a whole bunch of dots over here. Okay, these are countries with high literacy rates and lower birth rates. Okay, but you're gonna see countries kind of go like this. Okay, and so overall, there's kind of a trend like that. And we would say this has a negative trend. Negative trend, association, or relationship, whatever you want to call it. Okay. And that means larger values of one variable generally correspond to smaller values of the other. positive and we have negative. Alright, so let's tell me what has positive relationships and what has negative. Okay, so I'm going to throw out a situation. Now don't shout out the answer, but think of the answer in your head, and then I will reveal the answer. Okay, and I ask you don't shout it out because I want everybody to kind of think for themselves and think of something in their mind, and then we can all check whether we got it or not. Okay, so altitude. Okay, so think of the altitude of a location. Is there a positive or negative relationship with the air pressure? Okay, so think of your answer, don't shout it out. Altitude and air pressure. Okay, and the answer is there's a negative relationship. In general, places that are higher, okay, higher in altitude, the air pressure there is lower. Okay, the air pressure as you, so in Denver, the air pressure is lower than it is down here in Los Angeles, and that's why sporting teams that go to travel to Denver, sometimes they might get winded, okay, because the air is thinner up there, right? Okay. Okay. What about in a classroom? If we compared students' midterm scores with their final exam scores, okay? Think of whether this might be a positive or negative relationship. Students' midterm scores and their final exam scores. Okay, you guys have something in your mind? Okay. This is going to have a positive relationship, okay? In general, students who do well or score high on the midterm, in general, score higher on the final exam. Okay, in general, students who do poorly on the midterm also do poorly on the final. Okay, of course, there are students who buck the trend, but that's the overall trend looking at scores across the board. Okay. Let's do one more. The temperature outside and the amount of ice cream sold at Baskin Robbins. Okay, think of is there a positive or negative relationship? Just think of it in your head. So the outside temperature and the amount of ice cream sold at Baskin Robbins. Okay, and the answer is there's generally a positive relationship. Okay, if it's really hot outside, high temperature, they're more likely to sell more ice cream. Okay, if it's cold outside, low temperature, you're going to sell less ice cream. Okay, in general. All right. So, how do we do on those? Good. Good. All right. So that's positive and negative relationship. Okay, and then we also we can talk about the strength of a relationship. So when we talk about positive and negative, that's the direction of a relationship, okay? So positive and negative will describe the direction, but we can also describe the strength. Okay, so strength. We can have strong relationships or weak relationships and something in between. All right? If it's a strong relationship, indicates that we can make very good predictions of the other variable if we know one variable. So a strong relationship says if we know one variable, we can make very good predictions about the other variable. weak relationship says that if we know one variable, our predictions of the other variable are not that great, okay? So we can't make very good predictions. Okay. So let's think of a couple examples here. Okay, so let's say we looked at someone's shoe size. Shoe size is one variable. And then let's say the other variable is we actually got out a ruler and we measured the length of the foot. Okay. Are we going to have a strong relationship or a weak relationship? We're going to have a strong relationship, okay? If we know someone's shoe size, we can probably predict very well how big their actual foot is, okay? It's not going to be perfect, right? Because some people prefer to wear shoes that are a little bit big, and some people prefer wearing shoes that are a little bit small, and maybe if they prefer one brand of shoe and they say, you know, I wear a size 10 in Converse or whatever, maybe we find out their feet are actually bigger than someone who says I wear size 10 in Nike or something like that, okay? So, but overall, we're going to have pretty good predictions, okay? And it's going to be a positive relationship, right? Because people who wear larger shoe sizes, the length of their foot will also be higher, okay? So they are positive, and this is going to have a strong relationship. But on the other hand, what might not be as good? Okay. Let's say if we looked at someone's the length of their hair and the length of their foot. Okay. So we'll say length of hair versus length of foot. Are we going to see any relationship?
No.
Is it going to be? I'm going to say if we looked at a whole bunch of people, there's probably going to be a weak relationship, a very weak relationship. But I'd say there is a slightly weak relationship that does exist, and it's going to be negative, okay? And why is that? Yeah.
Women usually have longer hair and smaller feet.
Women usually have longer hair and smaller feet. That is exactly why, okay? So we're not gonna, it's not gonna be a super strong relationship, okay? Because you're gonna have a whole bunch of women, some with shorter hair than others, okay? But in general, you're gonna have kind of two clouds of people, okay? You're gonna have men who generally have shorter hair, okay, some men have long hair, but in general, you're gonna have people that kinda over here, and you know, you're gonna have some people, but then overall, so you're gonna have people all over the place, okay? But in general, probably the biggest concentrations of people will be kind of in this negative relationship here. But yes, you will have people all over. You're gonna have people with short hair that have small feet, people with long hair who have big feet. But overall, probably people with smaller feet or people with long hair might be more likely to have smaller feet than people with short hair. Okay, if you guys are kind of able to follow that. Okay, so you're gonna have a weak relationship. And a negative one. Okay, so the overall trend might look something like this, but how good are your predictions going to be? Not very good, right? Someone says, oh, let's say I have someone behind this door here, okay? And this person's hair is long. It goes past this person's shoulders, okay? Maybe about mid-chest or middle of their back. But I haven't told you whether this person is male or female, and I ask, well, what size shoe do you think this person wears? Okay? So you have no idea, right? All you know is this person has long hair, okay? So based on knowing that this person has long hair, you might be more inclined to say probably female, and if female, probably smaller feet. But we have no idea. It could be a female with huge feet. It could be a female with small feet. It could be a male with small feet. It could be a male with huge feet. We don't know. But probably the most likely choice will be probably female, probably smaller feet. Okay? Are we okay with that? So, you know, it's a lot of generalization, a lot of kind of just this overall trend business, okay? And of course, any individual may or may not fit the general trend, but that's what we have with a weak relationship. Okay, weak relationship, your predictions aren't going to be that great, but there still might be a trend. Okay. So we've talked about the direction, we've talked about the strength, and then the last thing we want to talk about for a relationship between two numeric variables is the form of the relationship. And here, a relationship can be linear or it can be nonlinear. Okay, and we're just going to say, in this class we're only going to be dealing with linear. Okay, so form is also called the shape. Okay, form/shape, and we have linear and we have nonlinear. Okay, so a linear relationship means the overall trend can be described with a straight line. So within the word linear, you see the word line. And it says the overall trend of a relationship who else? I don't know. Described with a straight line. Okay. So both of these relationships here are linear because we can kind of draw a straight line through them. But if we have, so let me just, I'll just leave this and say this one is linear. Okay. But if I draw another relationship, and a straight line doesn't work, then we say this is nonlinear. Okay. So, and this is a overly simplistic view. Okay. If you take another statistics class that gets more in depth, they might talk about all the different forms, quadratic and exponential, and different forms of relationships. But here, whatever. We're just going to say linear versus nonlinear. So this just means a straight line will not describe a relationship. Okay, so this one, linear, and it's a strong relationship. But, so we might have, so if I looked at your driving speed versus your gas mileage, okay, we will have a nonlinear relationship. All right. If you're driving at 0 miles per hour, what's your gas mileage? 0, okay? If you're idling your car and you're just sitting in the McDonald's drive-through line, okay, moving 0 miles per hour, your gas mileage is terrible. You could burn through all of your gas and travel 0 feet, okay, or 10 feet. Go ahead, you can, if you do that, all right. Now, if you drive slowly, okay, your gas mileage will be a little bit better, but you could, if you just kept driving 5 miles per hour, you wouldn't get very far, and you'd still burn all of your gas, okay. Now, as your speed goes up, okay, your gas mileage is going to get better and better and better. What's the most optimal driving speed if you want to get the best?
50.
Yeah, around 50, okay? Cars today are designed to get the best gas mileage around 50 miles per hour. 50, 55, some 45, some a little bit higher. But around 55 miles, 50, 55 miles per hour, you're going to get the best gas mileage, okay? And but then if you start driving faster and faster than that, your gas mileage gets worse, right? So if you're driving really fast, going not 70, but like 80 or whatever, you're going to use your gas a lot faster, okay? To the point where your gas mileage decreases. So this will be the speed of your car versus gas mileage measured in MPG. Okay. So at a certain speed, around 50, 55 miles per hour, your gas mileage is the best. Okay. So if you find yourself really low on gas, just cruise nice and slow in the slow lane around 50 miles per hour. You'll probably get to where you need to be. Even though all the other drivers around you might be angry. Okay. And there you have it. So this would be a nonlinear relationship, okay? And in our class, we're only going to learn how to analyze linear relationships, okay? So, but you got to know that nonlinear relationships exist, and if you come across one of those, all you can do is say, we haven't learned how to describe this yet, okay? All right, so what are the 3 things you want to use in describing a relationship?
Form. If it's positive or negative.
Yeah, okay, so the 3 things we want to talk about when describing a relationship.
Screen.
All right. Okay, so first is direction, and that is whether it's positive or negative. then strength, strong, weak, or something in between. And then the form or the shape. Linear versus okay, and so that's for describing a relationship between two numeric variables. Okay, we still have a lot to cover, but let's just take a quick break. We'll come back in 10 minutes, and we'll finish out the chapter and topic.